It's been a little while. I got sick, and then we were pretty busy shipping out a bunch of pre-orders for Bridge 6s, as well as working on some new products, which we're really excited to announce. So we're coming back to the Strymon MIDI-fi project, which is going to be a gizmo, so an open source product that we release. And we are, a bit of a catch-up, midifying an original, a V1 Strymon Deco, and then sort of from there making a control board that is a replacement control board for the top board in any of the Strymon small box pedals that you can sort of retrofit in. You can do it yourself. You can order the board through us, and all of the files will be freely available online if you want to go full DIY. And it gives it full MIDI control. We're talking you get presets, USB, MIDI in and out on separate jacks, not as sort of a shared bi-directional jack, which is nice. All sorts of really cool stuff. So we're picking back up from where we were. Let me bring up these files here. So I made a couple of just tweaks to the schematic. Sorry about that glare on my glasses. That's not ideal, is it? Is that any better? A little. Oh well. Yeah, I made a couple of tweaks to the control board. I did have to remove the WIDI module on here. I think it was becoming a little bit too crowded, and you can always add a WIDI jack, on the outside, and sort of having an optional like hole to drill. It just became sort of, pretty messy in terms of what was required for this product. So anyway, let me jump to. Just bring up my screen here. So welcome if you're tuning in. It's good to have you. Come and drop by for a chat. Say hi in the chat. Love to see what you guys are up to. If you're working on a project or you're just doing whatever, drop by, say hi. I want this to be really interactive. So it's a little bit, I don't know if it's just my end, but it looks a little low res. I hope that's not coming through in the stream too much. Let me know if it's a big issue. Anyway, so our main board is here. It's pretty much finished. We've got a couple of wires left to route, so we'll be doing that and hopefully sort of finishing up all the hardware and probably packaging it all up to send away. And then we'll be starting on the firmware, which is really, really exciting. So before we go any further, I'm just going to push this 3D model of the board. Push a new 3D model. All right. Come on. And every day I use Fusion, let me just bring that down a little bit. How's that? It's a bit better. Kind of thinking, should I make the jump to KiCad or KiCad? Is it worth it? Should I not? And I kind of just, it's hard. I'm such a creature of habit, and I've got a workflow that works well enough in that I know all the quirks. I'm really around them, and just the time cost of switching. So not only, the loss of productivity as you learn a new set of software tools, but the the opportunity cost of what I could be doing in that time instead, the time it's going to take me to sort of because I've got a lot of custom libraries and things like that for Fusion that I use, especially for open source stuff like this, that it's sort of just umming and ahhing a little bit. Fortunately, like if you've been keeping up with Fusion 360 updates with their like machining stuff, they've done quite a few things where they've sort of stripped or added new functionality in, but it's not available to hobbyists. So sort of the free version, so you have to have a commercial license, which is fine. But I hope they don't start doing like tiered subscription where you have the full version, but then because there's with the machining stuff, there's a lot of like add-ons. If you want the generative design, I think, or some of the machining stuff, you have to then buy that as well. So I really hope they don't start doing that with the electronic stuff where, cool, well, unless you sort of buy this extra subscription on top of the full version, you know, you're not going to get these things. If they do that, I think it might be the nail in the coffin for me. But, you know, for now, I can get plenty done, so that's fine. So anyway, here's our project, our PCB. So we've got our a little chum coming in to say hi. Hey, buddy, Daddy's just working. You want to come and say hi? Come up here. Okay, come and say hello. We're designing a PCB. This is Daddy's work, isn't it? Yeah. So we don't have a footprint for these connectors here, but you know, those placeholder boxes are fine for now. All right. Yeah, buddy. Oh, Uncle Paul's not here at the moment, buddy. Uncle Paul's not here. Sorry, mate. All right. Let's get out. Love you, mate. All right.
Because you know, this is the last.
Dad, just close the door. Sorry, I'm live on stream. All right. Where are we? So, yeah, a couple of changes. We switched to, I just switched to a smaller crystal package there. We removed that, and we're going to go ahead and finish the routing here. So, without that big WIDI module, we can certainly simplify some of these trace runs quite a lot. So I'm going to go ahead and I'm going to go through this fairly quickly. You know, we're been doing quite a lot of this fairly slowly and walking through different steps as I go. But you know, we're at the pointy end of the project now, so we're going to sort of knuckle down and get it finished. Just bring some of that, tighten up some of those traces. All right. So we've got a couple of traces to run over here. Then we've got we need our SPI coming from our SPI bus, coming from our ADC. We're going to need to sort of tidy up a lot of the labels here. Before we do, I'm just going to do a library update. I made a couple of changes to some footprints, in particular my SOD 323 diode. I just made the pads on it a little larger to help with the sticky sort of, so there's a bit more solder paste on the pad for the pick and place process. All right, so this is going to be a 4-layer board, remember. So whilst we are trying to keep everything on that top layer wherever possible, we do have that bottom layer to use. Originally, I was hoping to keep it as a 2-layer board, but from a complexity standpoint, it just wasn't going to happen. So now we've got this PWM channel, so let's escape it. All right, bring it up to here. I'll stop pushing that. All right. So I think the best way, because the other thing is we've got this VREG out here, which I think we're probably going to keep on the top layer and go underneath the chip there. It's probably, so I've used that sort of before. So we've also got this VREG out here. So I've used that method for routing on the RP2040 before, and it works perfectly fine. It's pretty tidy solution to that routing requirement. And I'm using 8 thou traces there. Straighten that up. I might just extend that to a 12 thou, I think, especially while we run across here, so we just can keep that inductance a little bit lower. But we are going to run over that serial wire debug line. So yeah, maybe if we straighten that up. And we'll go down the bottom here, I think. Well, you know, we want to keep a bit of clearance from that ground pad, but we also want to allow room for vias off those pins if we should need it. All right, that's pretty good. Move that a little touch closer to that pin there, give it a bit more space. All right, what else have we got? I've got this V-Bus Sense pin over there, which we kind of need to get through. This is going to be a little bit tricky. We're just going to have to think about this routing. So I think if I take that V-Bus Sense pin still on the top layer, we can actually escape it all the way down there. And that's going to be fine. So it can come up here. Now, strictly speaking, ideally you don't want to be running sort of signals under bypass caps like this as a general rule of thumb. We don't want to be running stuff underneath these this USB termination. That we will abide by. But with those decoupling caps, it's not really a big deal because this V-Bus Sense pin isn't, like a switching signal. Do we have enough room to go down here? Maybe. So it's not like a high-speed digital signal that's going to be causing transients kind of under those decoupling caps. It's really a steady voltage, so it's not really going to cause any issue. Strictly speaking, it's not the best practice, but again, it's not really the end of the world. Not really the end of the world. All right, clean that up a little. That's a bit better. Perfect. Okay. What else have we got? All right, LED, L and R, like analog sense pins, really. We might just thinking we might flip those around and bring them sort of down and along here, perhaps. So if we rotate those around like so, like so. Then we can route these like this. All right. And then what is going on? All right. We may actually have to sort of move that because this decoupling cap here is going to need to go to our 3v3 there. Now I've done something kind of silly here. I don't know if you can see. I only realized I went autopilot when I was placing these decoupling caps and put vias next to this through hole pad, which makes no sense because typically you're putting the vias there so that you can drop down to a power plane, which we will add, but it makes no sense because it's going right to this big through hole pin here. And these aren't strictly decoupling capacitors, they're more just filter capacitors to help with the noise. So I want to make sure I get rid of those because there's no point adding vias when we really don't need it. Something I do note though is if we move this, I'll do that right away, and I'll switch to a 12.5 thou grid, is if we move this just out of the way there a little bit, in fact, going back to our 3D model, could even go sort of in under there. Although I was trying to avoid that. I don't know. Well, for the sake of cleanliness, we won't put it underneath the pot, I think. That's fine. Then we can just run our power over to there. And now what we might do, switching back to a finer grid, is hello and welcome if you've just tuned in. Say hi in the comments. I'd like to know what you guys are up to and all of that jazz. Finishing this off. Now we should have room. We might have to switch to 6 thou traces, but should have room to. Oh no, we'll be fine. Be fine. Plenty of room. Now, on a completely unrelated note, for those of you, not who aren't Australian, FYI, this coming Sunday evening, the NRL, the Rugby League Grand Final is happening, and my team, the mighty Penrith Panthers, will be taking on the Parramatta Eels, who this is a sort of public stream. I'm not particularly fond of them, but if you're over in the States or Europe or something like that, and you want to get a taste of one of the pinnacles of Australian sport, then tune in. It's 7:30 kickoff Sunday evening, Australian Eastern Standard Time. Just as a bit of a shameless plug, Penrith are amazing. Now, let's get back to some PCB layout and routing. If we come down here, then we can sort of skirt around there. And, again, I could take that down to the bottom layer right from up the top, but I want to be able to just have that SPI bus coming there without any, major interruptions. And we've got the board space to do it. What is going to be tricky, and we're going to have to shift these bottom layer traces out of the way. Oh, it doesn't like that via there. Now, those of you who are, do design PCBs might be about to shout at your keyboards, but I'm really not a fan of push and shove routing. I don't like the program moving traces somewhere that I have not explicitly told it to put them. So I typically will sort of go and hand fix those things. That's just me though. All right, now we can, if we wanted to, we could run down and around, but I don't want to. So instead, I think we're going to call it a day on that top layer. Might kind of mosey on up to here, like so. Chuck some vias down. Like such. That's going to that outer one, isn't it? All right, so we can kind of go down and around here. But then, yeah, we are going to have to jump back up to that top layer. So I have to move that trace down a bit to give us enough room. Do something like that, I think. It's a pretty reasonable solution. And then we can come down through to here. Up to our top layer and to the pad. It's not too bad. Well, I might just now drag that down so I don't have that little kind of notch, sharp angle there. All right. It's looking pretty good. I'm pretty happy with that. We can certainly bump that up a bit. Just clean those traces up a touch. Alrighty. Habitual save. Everything's looking pretty good. I actually made a mistake when I was doing another RP2040 based board on the Spire. This is, so you can get there's two really common footprints here. You have SOIC 8, so small outline IC 8-pin, and they normally come in 150 thou, so 0.15 of an inch across, but you can also get 250, I believe. The other one, this is 150, and I ordered a bunch of flash chips and just sort of didn't even think and ordered the extra wide ones, and so that it was a bit of a hot mess, but I was able to make it work. We're definitely not going to, I don't think we're going to use a 2 megabyte flash chip there. With the RP2040, because you're typically using, you can use C or C++ via the SDK. You can use Arduino, or you can use MicroPython or CircuitPython. But to do that, you actually are installing the sort of the interpreter or you're installing CircuitPython or MicroPython onto the flash chip, so to speak. There's code running off that, and it's interpreting those instructions because it's an interpreted language, not a compiled language. And I believe that to do that, you need about 1 megabyte sort of for that. And so really, if you're doing that, a 2 megabyte flash chip is required. Now, I could be wrong. It could be, you only need 1 megabit. Pretty sure it's 1 megabyte. So scaling of 8 there. So I don't know, like I was thinking we'd probably just use Arduino so we can, it's going to be quick and simple and easy for people to modify and understand the code on it. In which case we can pretty much use whatever flash size we like. We can use something tiny. I used a 2 megabyte chip for another project, and I was using 0.5% of the total flash. So it's 2 megabytes is certainly overkill, but we might leave that larger size on. So if folks want to use CircuitPython or MicroPython, then they can. I don't know. We'll see. We'll see. Okay, this this PWM channel here, pretty sure there's not really room to get it up and about. It might be worth actually bringing it up on the top layer down here so that we can keep that sort of not running too many traces under the board. Yeah, we might. I don't know. I just don't know. No, it's not going to be a big deal. We'll take this here. Run a via there. Now we're just going to keep clear of that. More violators, thank you. Keep clear of that ground pad because we are going to drop some vias down there for the ground through to our ground layer. And I don't want to run sort of underneath that, even though it's going to have ground in between. I don't want to run underneath our crystal circuit there. So take pains to stay away from there. Like ideally, we only want to have that ground reference layer, nothing else underneath there. Okay, now our SPI bus. So first of all, we're going to need to break these out to, I've been using a larger via than I normally do. We'll use the small ones. Break these out to the bottom layer. I'm going to take some of them, sort of put the vias on the outside of the, or not underneath the chip here, to just try and keep things a bit more spacious, a little bit more kosher. Like so. Because ideally, you don't want to have those vias underneath the chip, because it means if you're trying to probe around or debug something or just, look at some signals, it makes it a lot harder if things are hidden away. But sometimes you don't really have much of a choice and you've got to do what you've got to do. So here we are. And we've also got the chip select pin here. Okay. So I'll bring these down on the top layer down here and we'll see where we get to. We might sort of use this space in here as for some of our vias to transition to that bottom layer. I'm not sure. It's looking a little messy. Let's try coming down like this. Okay, yeah, that's not too bad. And then we can where are we? Then we can transition that. Oh, stop zooming us. Stop zooming us. Okay. Any of you guys, by the way, who do a lot of firmware development or things like that, I recently switched to a Logitech MX Master 3, and it is like no hyperbole. It is game changing. It's got this infinite scroll wheel, and you can kind of just so it can ratchet like that. But then if you give a fast click and you can set the sensitivity threshold, it can sort of free run scroll. And so if you're scrolling through lines of code, you can just quick flick and it just zooms, down your file. And it has been a game changer for when I'm doing, lots of firmware development. It's just amazing. I love this mouse. It's really comfy, really ergonomic. If you honestly get one and try it out, they're not even that expensive for, a decent quality mouse. It's got Bluetooth and 2.4 gig options. Fantastic. All right, so shilling aside, let's bring that bottom trace down because it has to come down to that side there. Need to steer clear of that ground pad. I'm going to give it a bit more space so we can make sure we come around from that ground pad. I'm concerned. I haven't put vias on these 3.3 volt signals here. I'm just looking at that now. I need to do that before I keep running these spy bus traces because they are going, that clean power is much more of a priority than anything else. So we might switch to a 16th hour trace. I'm going to connect these together here. Like so. And this might look a bit weird, you can see them running to the chip there and then running here. But the idea is you think about, strictly speaking, these should all have their own via to the ground plane. And in fact, what I might do is in between these two, we'll put a via just to sort of be a little more pedantic. So these two pads here are sharing a via, which isn't strictly best practice, but it's not a big deal because you think we've got power coming in through these vias. They still have to pass through these decoupling caps before they get to the chips. They are going to give, reasonably effective localized decoupling. It's not too much of a big deal, and it just saves turning, our ground layer into Swiss cheese because we're not using blind buried vias or anything fancy like that. And whilst we do want to have, we do want to have a really good decoupling and put the emphasis on that. It's also a bit of a trade-off because the more vias you place, the more holes you're going to have in your ground plane, and the more you're going to be sort of, tearing up that. What you really want is a nice untroubled ground plane. So, like with just about everything in electronics, it's always a trade-off. So we're going to move that out a little bit. I don't really know what I was thinking with not placing these vias here. And that via, I want to get this out of the pad. You can put vias in pads, and we're going to use that for our ground pad. But for most parts, you really want to avoid that. For one thing, the V will cause a bit of an uneven surface on your pad. Like if you've got, let me find a board, but let's say you've got a board. I don't know how well you'll be able to see this, probably not at all, but you've got this pad, right? And ideally you want that to be a perfectly flat piece of tinned metal that you can solder to and get good adhesion to. But if you have a via, because it is a drill, even then when plated, it's going to be slightly uneven, which is going to reduce the surface contact on that pad. So that's not ideal. 2, if it's really close to the pad, you can get, when you put your solder paste, your solder mask, which is going to cover, you expose that pad so you can solder to it and everything else is covered. If you have the via too close, that solder mask isn't perfectly going to cut off that, some tiny little stub. You can get solder leak down into your via when you're reflowing because unless you use tented vias, a lot of boards don't, then you're going to wick solder away from the pad and probably get a poor quality solder joint because there won't be enough solder to it. So you've got to think about those things when you're, placing your vias. That's slightly closer than I would typically. I usually would like to place it one little grid line over again, but with this confined layout, it's actually a fairly reasonable solution. I'm just going to move this ground via away from our noisy crystal line there. In fact, we might just move this crystal network down and away a tiny little bit. So Something like that. Yeah, I'm a little bit happy with that. Just a little bit more separation from things. We can. So again, to keep our low inductance where possible, we are going to use these fatter traces wherever possible. But I am just trying to get some separation from the other signals as well. Like I said, PCB design, everything is a trade-off. Everything's a trade-off. All right, we might just change that. It's a little bit better in terms of clearance. All right, cool. What else? Oh, we need a via there. Sorry to kind of be jumping around so much, but I realized I'd done goofed up and really need to fix it. Hang on, I'm using a 16th thou there. All right, we'll put a via there. Like it'll tell us, we'll get an error when we go to do a design rule check if we haven't connected everything up properly, because it'll say, you know, you've got unconnected airwires. But like I realized that we've got this 3.3 volt line here without any decoupling. And I'm pretty sure that's because when I was looking at the layout recommendations, it said, oh, these pins share a decoupling capacitor. But I've got all these pins in here, so I might add a separate decoupling capacitor for that pin there. It might be the way to go, because looking here, yeah, pin 10 is not a signal line. It's one of these power lines. So we could probably just add, select these and that. Out a little bit more. There we go. Now, where's that other capacitor going? Oh, so just another 100 nanofarad capacitor. We'll try and make some room for it to go somewhere here-ish. In fact, that's actually not a bad spot for it. I'm not too worried about getting it perfectly close to the pin, because originally we weren't even going to have that decoupling capacitor there. So something like that is certainly much better than the alternative of having nothing. Okay. Escape it out there. Beef up that trace. Place a via there. I actually use this. So this layer here is a keep out layer, and it basically says, you know, don't if you have keep out layers overlapping with each other, then it'll give you a warning. You can use that to make sure you don't place components too close together. And I actually like using that as a bit of a guide for where to place my vias away from the pads on these 0603 components. I love coffee. Okay. All right, I like ground pins. Have vias, that's nice. All right, that's looking a lot better. No via here to 3.3 volts, because I think it must have just been when I decided we'll change from a 2-layer board over to a 4-layer board. I sort of forgot to go back and tweak these things, because with a 4-layer board, we're going to have an entire layer just as power. So that's going to be our +3, 3.3 volt rail there. All right, now coming back to this SPI bus. So I think that's going to be our next signal. All right, well, I want to get through those. Those vias there. Okay. Everything is back to front. That's quite frustrating. Well, we are going to have to run Oh, that's really frustrating. All right, that's okay. We'll just bring this via all the way down so then we can bring our bottom layer down like this. We'll actually use the bottom layer this time, down like so. Probably go this side of the ground pad. Down to our via there. And I'm just going to try and make a bit more room around that ground pad there. Okay, cool. And then, oh yeah, we're still going to need more room. Like so. Okay. Now I'm going to move, just separate these a little bit so I can keep a little bit more separation between those lines to reduce the crosstalk between them. So, you know, it certainly doesn't have ideal, perfect separation, but anything's better than nothing, right? That's a bit better. Then we can give that ground pad a bit more room, a bit more clearance. Okay, cool. I'm pretty happy with that. That's not bad. Really clean that up a touch. All right, great. Move that veer away. Just try and, you know, keep everything a little bit more separate wherever possible. Cool. Okay. All right. Oh, actually, while I'm live, I know this is sort of probably not the done thing, but just jumping over to Slack, where I believe Warren was just asking about controlling an amp, which is actually really exciting. Because we do have a product coming out that's going to do this. So give me a second. Reply to him. Sorry, this is probably bad manners on a stream, but bear with me. Okay, and coming back to the stream. Sorry about that, everyone. All right. There's a couple of traces here that, you know, there's unnecessary bends and bits and pieces that I want to just try and clean up a little bit. Oh, there we go. Get rid of some of those. Cool. This is all looking really nice. You know, a quick glance, and it doesn't look like there's any. There will definitely be some airwires that I haven't routed yet. But it looks like pretty much everything is routed now, more or less. What we will do, we can go rats, use this command, and it's going to sort of, all the airwires that we hid, it's going to then unhide. So we've got our top and our bottom layers. Now we've also got these two internal layers. And this isn't the best 4-layer PCB layout in terms of EMI performance. So if you were looking to make a product and get it certified, you know, then you're not going to want to take this approach. Basically having your outer layers, and it's not even with EMI, it's just about signal integrity as much as anything. If you've got your two outer layers, right? Think of your stack up here. You've got two outer layers, then two inner layers. Now, ideally, every signal layer should be adjacent to a ground layer because your return current is going to be directly underneath the trace. Okay, so even though you've got this big ground plane, your return current is going to be underneath the trace. And this is outside the scope of this video. It's quite a complex topic. Phil's Lab and Microtype Engineering have some really good videos on this if you want to check out some other YouTube channels. They're fantastic. This is a quick abridged version. Basically, in an ideal world, every signal layer would be, you know, sandwiched between ground layers in theory. With a 4-layer PCB, it makes it a bit tricky because if you put your signal layers next to each other, then you can get crosstalk between them on the inner layers, and then your power and ground on the outside. So it's always a trade-off. What can be a good option, having them on the inside sort of does shield them from the outside world, though. You can then alternate them, so you can have signal, ground, signal, power, which is pretty good. But then your power and your ground planes are further away, and so you get reduced capacitance between them, which again is also not ideal because you want to have good capacitive coupling between that those power rails. So it's all a trade-off, but for this kind of thing, you really don't need to worry about it. This sort of stack up for a 4-layer board's fine. So we're going to make a polygon, 3.3 volts. Now we're going to do it on, so our power layer is going to be this bottom one. Most of our signals are on this top layer, all right? And having a ground plane adjacent or as close to possible to that layer is critical. So I'm going to use this layer 2 as my ground plane. So purple layer, layer 15 is going to be my power plane. I'm going to go to a slightly coarser grid. Actually, maybe slightly finer than that, because I have found, and this is just a personal preference thing, what I try and do is lay out my ground planes, or my any planes, just inside the my board outline. So that way, when I'm panelizing them, I don't have these overlapping polygons, which can kind of short across board panels or just cause some issues in general. So I'm just going to make it a big, as long as it's inside the outermost extremities of the board outline, which it will be for that. And I'm just using the same imperial grid to be a little lazy, but okay. So that's outside. So I'm just going to kind of bump it up one. Great. We can scoot up to here and close close that off. All right, cool. So you can see here we've got this circle out, kind of isolation between our pad, and that's because even though this is a square pad on top, it's not actually going to be square on those inner layers. It's going to be a plated through hole. So you drill a hole and then you plate that hole with copper, and then it's tinned or whatever surface finish you're using. So it's only that circular keep out that we have from here. Now I like to just check the so we do have our thermals and everything like that. I like to bump our thermals up to 8 or 6. It's fine. It's much of a muchness. We don't want hatched. If we go hatched, we can see we've got this hatch grid. I like to have a nice solid ground plane. We've got this isolate, and typically I like to, depending on the board, put a 5 or a 10 isolation. It just pulls everything back. So you see these vias, it just pulls it back. If I go to 10, pulls everything back a little bit, and that can just help increase your manufacturability of your board. Obviously, you don't want that to then have detrimental effects to you have a whole bunch of islands and things like that on the polygon, but just doing that, it just a little bit of safety clearance around those vias, which is really helpful in just making sure that it's going to be manufacturable by anyone. So now we've got our 3.3 volt plane. We're going to go ahead and do another one for our ground layer, again on layer 2, adjacent to that top layer. Just going to help with our signal integrity a bit. And this isn't a very complex high-speed board. It's got nothing too crazy going on. And there's our ground, like so. So we can see I like to then just hide those layers because I find they clutter things up a little bit. So we can see that we've got these, our ground. When I was originally thinking that it was going to be a 2-layer board, I would put a ground pour on the top and the bottom layers, so I wouldn't need to actually connect these ground lines up. But now that we're not doing that, I don't like to put a ground pour on the top and bottom if I can help it, because it's going to increase the thermal mass of the board quite substantially, and we really don't need that because we've got this big solid reference plane. All we want to do is just ensure that everything can get a good reference to ground. Okay, so I'm not going to tie things to the ground of this potentiometer because that's part of our analog circuit. I want that to go to our ground plane separately of this digital circuit with our LED. All right, so I'll probably use a 12th hour trace for this. So it's going to switch to a finer grid. So V is going to go, closer to the decoupling cap. So I'll probably put that there. That looks nice. And we'll pull that away from that pin there. So you can see now goes away. That air wire goes away. I've turned like dynamic air wire off for some reason. I'll have to take a look at that. So the last thing that we will need to route then is this 5 volts, and I'm probably going to do that on the bottom layer, but I want to sort this ground out first. So we're going to go ahead and connect up all of these grounds that aren't properly connected. Okay, so here I'm going to get rid of this trace and bring it underneath here. Make some room so that I can connect to the ground pin of this addressable LED. Make sure there's no wire stubs hidden in there. The ground pin of this LED directly to the decoupling capacitor, because that's going to be much more important. All right. Up a bit. Cool. And we're just going to go ahead and do this for every LED. It's going to be pretty much the same approach. I'm going to take this line here, go down underneath the body of our LED so that we've got room for this ground. And you'll see when I'm, kind of the shorthand way of creating a via in Eagle is to just switch to another layer. And I'm switching to the bottom layer, even though that's not our ground layer. It actually doesn't matter because these vias are going all the way through the board. They're not blind or buried only on certain layers. It really doesn't matter. And while I'm here, I should connect up this 5 volt power here, and then also run a via so we can run our power along our bottom layer. Like so. Cool. I put that here, but I clearly didn't put a via down. Alrighty, I'm just going to go ahead and do the same thing. We're connecting up our ground, making sure we've got 5 volts routed out. With the via, of course. So I'm sort of umming and ahhing on this project, what IDE we'll use for the firmware. There's a part of me that would really like to dive into the official SDK for C and C++. That'd be a really fun experience. It's just that for this sort of open source project where, and this is dragged on a little bit because we've just been so busy and had some interruptions. I also want to get it done. And so using something like Arduino to just get it done will be the quickest method. I'm definitely not a Python expert. Like I can get projects done in Python and can, know my way around the language well enough, but it is going to be a little more clunky on stream to do so. Whereas Arduino is just going to be a pretty quick and easy solution here. And man, I just ham-fisted some of these connections. I want to just connect this cap directly to that ground pin. And no, I haven't, so I've got to go ahead and do it. There's a lot of ground pins I just didn't think about or didn't bother connecting up. which is kind of annoying. For there, I can't get a really clean connection, so I'm going to leave that. Our pot pin, obviously through hole, it's going to go to the ground layer anyway. We'll just run a via down to there. Okay, so these aren't carrying really any power, so we'll just pop a via here for all of these ground points. Nice and quickly. Just remember, this is the input filtering, the low pass filter for our potentiometers. We can just connect that to there. All right, how are we looking? Oh, we've got these serial wide debug pins. Oh, of course, that's our reset pin, and we've got that pull up there. So why is that not aligned to the grid? Oh, I probably just moved it around roughly when I was in a metric grid and just kind of roughly laying out components, and never came back and cleaned it up. There you go. All right. This is our reset line, so it's, not only is it not high speed at all, but it's very rarely actually used in, we're not really going to be programming this thing much apart from via USB, and so this sort of reset circuitry really isn't critical in any way. So we'll just drop a via down on that 3.3 volts, and likewise to there. Great, takes care of that. Yeah, so that's that 5-volt line. Oh, we've got it all here in this ADC as well, which we're going to have to run sort of Vs to and connect up all our power, because we only did the signal for this. Oh, well, they share. I'll probably just run a via in the middle there and connect to it like so. All these 3.3 volt lines we can really just sort of connect via a couple of vias because they're not decoupling for any sort of switching IC, so inductance isn't strictly necessary. This is just our sort of our DAC circuit, so connect those up via a via there. What else have we got? We've got some grounds that we need to get vias for. Like so. It's looking good. All right, and of course that's actually ground for our op amp. So, now I'll have to check what op amp I spec for this. I put an LMV, 324, great. Very typical op amp that'll allow us to go right down to the ground rail. Good LMV 324, it's one of those jelly bean op amps, but it is really nice where, unlike a TLO 74 or something like that, you can run it all the way down to the ground rail, whereas a TLO 74 you can't. There's sort of like a it's like not point. So I'm thinking 0.7 volts for a diode drop, but it's something sort of around, like ballpark around there that you lose as far as your lower headroom, which certainly is not ideal. So for if you're doing single supply design, something an LM324 is going to be a much better choice than a TL072 or a TL074 because of that. I am guilty of just jumping to a TL074 whenever I need, or an 072 whenever I need an op amp. As much out of habit as anything, I built my first circuits, and that was what my local JCAR had lots of, the TL072s. And so I just would use those, and their performance is fine for pretty much most audio circuits where you don't need crazy precision. And it sort of just became what I would reach to when I'm drawing a schematic. But, you know, everyone has those parts that they just use out of habit. Okay. Lovely. Of course. Ground via there. Okay. Ground via that one too. How's that looking? It's looking pretty good. We've obviously got to connect up our 5 volts. We're just looking for any, 3.3 volt of ground connections, which will get our vias too, because like I said, we're going to run our 5 volts along that bottom layer. So I'll put some vias in where I see them, or if I remember to. Right next to that decoupling capacitor, good place to put a via. It's a trace a little wonky there. Fix. Ugh, let's just get rid of that. Don't know how that happened. All right, that's a bit better. We need a via there. Now, something I actually caught. I made the dumbest mistake of all time. Someone was probably throwing something at their screen, just yelling at me to not do what I did. While I think of it, in the RP2040 layout, I thought, oh, I'll go ahead and label these nets, and things like that. And just I went full autopilot. And I named this net VREG in, which overrides this naming of the plus 3.3 volt signal there, which meant that the input to the regulator, which is built into the RP2040 chip, it regulates down to, I think, 1.8 volts for the core, wasn't connected to 3.3 volts. So I was trying to work out why my chip wouldn't boot up. And I was so confused. And then I looked at it and just realized, oh. So yeah, if you have gone back and watched that video, I sincerely apologize for that boneheaded error. All right, those op amps have ground connected. They've got 5 volts. This needs a ground via there. Actually, what I'm going to do instead is on this guy, I can run this up to here. Saves vias. Still going to be a nice low impedance connection for that. What's with these wonky traces? Oh, I know why. I know why these traces are wonky. So, all right, I'm going to go ahead and fix that up. I actually realized I had an error in, pretty much any of these ones. I'm going to go and redo them, see how they're all a bit wonky. I had an issue with my TSOP footprints, both TSOP 14 and 16, where somehow along the way when I made them, I mucked up the pin spacing, and so it was just a little bit too narrow. I think I must have been like in the wrong, thought I was in metric when I wasn't, or something like that. And so they all, I had to redo them, because they weren't right. They were slightly off, and even though it's not a big deal, that can be enough that you don't get good surface tension during your reflow, and it can cause issues. So realizing why they're all wonky, that's exactly why I went ahead and refreshed the design. So any library changes would take effect. And I obviously just forgot about that particular change. There, you can see they're all just looking really weird and bent at weird angles. And ideally, for neatness sake, unless you're doing very specific PCB layout, and if you are, then you know what you're doing and you don't need to be listening to this advice. But unless you're doing very specific things, or you're doing an artsy type PCB layout, you want all your traces to be no other increments other than 45 degrees. So you have 0, 45, 90, so on and so forth. So they're all either straight or at 90, these 45-degree angles. So we don't want those weird, funky looking shapes. Whoop. Okay, we're looking. All right, almost finished fixing this. What really was just a dumb mistake. Very, very dumb. I need to fix these ones up as well. Okay, that's looking better. Go ahead and save that. And of course, we've got grounds down here on our power supply that we still need to route out. Now, let's kind of, do we use a pour or do we just use big fat trace? I'm just going to use traces, and with plenty of, yeah, I'm just going to use fat traces. I think it really is going to be more than adequate for especially such a low current draw kind of board. It's not going to make much difference. I'm just going to go to like big fat 32 thou trace. Right close to it, we're going to add via. And we'll connect these up here. I'm going to add another via close to that capacitor. So we've got nice low impedance. Oh, I didn't want that to be bottom layer. Got nice low impedance connections. Like so. Cool. And then continue on to there, where we'll have to use a thinner trace. So plonk a via down there, I think. Pretty good. Can we go and use a nice big fat trace there before we have to come down to a in fact, we will have to make that a via connection rather than connecting those all on the top layer, because we need to connect the enable pin for this regulator, pin 3, to our input voltage in order for the regulator to turn on, like so. Same thing for this 5-volt regulator. In fact, while I think of it, actually, I stopped using this small footprint of 5-volt regulator just because I tend not to use the SOT23 package 5-volt regulator, and so to save an extra reel on the pick and place, I pretty much, for 5 volts, exclusively use a SOT 323, or SOT 223, slightly bigger one. Anyway, so I'm going to go and change that footprint now. We'll delete that regulator. I'm going to go and add LDO 5-volt, just a bog standard LDO there. Whoop. Like so. Because, you know, if I'm using 5 volts, the 5-volt regulator is going to be powering the 3.3 volt regulator as well. Pardon me. So, you know, we don't want to be like, typically that current, I want to have a bit more current draw if it's going to be driving some LEDs off that 5-volt rail, as well as or a 3.3 volt rail. I want a higher spec current regulator than the SOT 23-5 regulator, which typically you're only getting in like 100 milliamps, 150 milliamp range, whereas this bigger boy you get 500 milliamps an amp. Easy. So even though it takes away some of the nice layout symmetry we had here, that is not a big deal. Oh, so what do we want our decoupling capacitor? Trying to think about the layout for this. Probably there. Then we've got our input here on the left. We can put. Then we can just run 5 volt along there on the bottom. Although it is a pain having to run 5 volts sort of back up to there. I am not the biggest fan of that. All right, well, we might, but then I've got to leave room for that connector. We really don't need that 100 nanofarad capacitor there. That's not necessary for both of those. It's really not. I'm not sure why I had that there. I think that was probably just in case, you can sort of put that there, but not needed, not necessary. Got a Voltic storage capacitor there for our 3.3 volts. Cool, yeah. That's looking fine, just fine. So put that nice and close there. And stability for the output, and then we can just go ahead and use like some 24th hour traces up to there. In fact, we might clean that up a little bit. I think I'm going to run that like that. It's a little neater. All right, now I'll put VR right next to that stability capacitor. Connect our ground again right next to that stability capacitor. I'll be connecting all of these to ground here. Too far down. So sort of just, none of this placement is particularly critical as to exactly where it goes, so we can rush through it a little bit, just make sure that everything is, well decoupled and has a good low impedance connection to our ground plane. That's going to be fine. All right, and then need to connect those pads there. Alrighty. Just annoyed that, thinking we'd get away with a 2-layer PCB, I didn't bother running any ground traces and vias for all this stuff, because it would have saved so much time if I just did it when I did the layout. Oh yeah, what am I doing? We don't need a via there. We can run a trace over to the switch connector. I need to Swiss cheese things more than they already are. Okay, so that's looking pretty good to me. Like I said, we still need to run our 5 volt traces. So we'll get to doing that next. And then we're pretty close to being done here. Save and then we'll zoom out. Yeah, this is looking really good. Yes, very important that we connect that ground pin there. Move that out of the way. Alrighty. And yeah, something like a 16, chunky 16th hour trace. Get a V nice and close there. The ground pin of that connector. All right. 3.3 volts here also needs to be connected. Of course it does. So it's less than ideal. This is why, folks, if you're watching this, this is a good lesson in just make a decision with what kind of board stack up and, topology you're going to go with, because it saves you so much time mucking around with this sort of stuff in the long run. We need a VIA here because we didn't think about that. All right. That's a bit better. We obviously need to connect our 3.3 volts. Get another VIA. And that needs 3.3 volts and ground going to it, doesn't it? That's decoupling for our flash. That's important. Make sure we get that right. And that's going to go directly to ground. I want that to be sort of dedicated. That cap is not on the grid. That's a bit better. All right, now for this, directly to ground. So that's going to our MIDI USB sort of satellite board there. Lovely, lovely. Now it looks like this pin's going to need ground. So we're just doing a double check over everything. We'll actually run a design rule check later to make sure we haven't missed anything. But for now, just running our eye over stuff is more than good enough to catch some of these nets that still need to be connected. There. Might thicken that trace up just a little bit. If for no other reason than so it matches. We'll give that a bit of space. Lovely. And that's 3.3 volts. Needs its own VIA. And remember, because they're separate analog and digital power supplies, we're not going to just directly connect them up. I want those to go via the plane, so it has a nice low impedance connection. Why is that saying it's not connected? I wonder. We might need to run a rat's nest again to just fix up some of those. Yeah, there we go. More ground, not connected. All right. Now, again, no need to run sort of a VIA for this because it's just some debouncing for this switch. So we've already got that through hole pad, which is going to function just the same as a VIA. I'm going to check this 5 volts. Oh, missed net there. That'll be handy. All right. 3.3 volts isn't connected. Oh no, that's just the plus there. Cool. Well, looks like everything's more or less connected up, except this 3.3 volt here. Again, just catching all these little nets that we maybe haven't connected or run VIAs for. No ground there. Cool. That is looking pretty good. And then I'm going to want a VIA for our 5 volt supply there so we can run. Why is that not connected? That's a little strange. Actually, what I am going to do for this is I am going to use a polygon and a pour, so that I can just run a whole bunch of vias to make sure that that 3.3 volt is nice and low impedance to our 3.3 volt plane. So change that fill width back to 8. No thermals on this one. We're just going to run a nice big pour to there. Now we can put some vias in here. So a couple kind of right next to the pin, next to our decoupling, next to this bulk storage cap. So we'll put a couple, probably put 3 across there. Now we're going to have a nice low impedance connection there. Now, whilst we could just connect a trace there, I actually want this 5 volt output to go right to the output of that ferrite bead there, so we sort of can take advantage of all of that filtering there. Because remember, that 5 volt regulator is only if we decide we need to power it from the 9 volt jack. We're not going to be using sort of both of those options at the same time. So what I really should do is put a never mind. I suppose that you know, because if we want to use, I don't want to be taking components off. Sorry, I'm just stream of thought here. Thinking about putting a solder pad in between that V in, so we can actually fully disconnect that pin from our connector to this circuit here, so we're not loading it down at all. Because we could just say, oh well, we won't place our ferrite bead here, but then we're still loading that with these capacitors here. And ideally, if we are going to power it off the DC supply, then you know, we don't want to introduce anything separate into that circuit. So go back to our schematic here. Jumping around a little bit, you can tell I'm feeling a bit scatterbrained today. All right, we'll keep that net there, I think. So we're going to just hack at this. I'm going to call that V in. Okay. Let me go to, I believe I imported some sort of nice like solder jumper pads from SparkFun. Yeah, we got these guys. I just want a 2-pin one. Yeah, something like that. Will work well. And silk or no silk screen, what do we want? What's the difference between those two there? Oh, just whether they're connected normally or not. We can do some round ones. Yeah, we're just going to go this one here with the silk screen outline. I'm going to put this jumper in. I hate how long that part value is. It's really kind of gross when you're looking at the PCB layout. All right. Now we'll rename that back to VN. So it's connected to our connector input. There we go. And now, if we go back to our board, we've got this jumper that we can either short with a solder bridge or not, as we want to. Why is that network still saying V in? I don't want that to be V in. Easiest way to just ensure it gets a unique name is to deconnect everything from it. Now, if we look at the name, it should no longer be V in yet. It's N13. Cool. Okay, so let's rewire this. What was I using? 20 gauge. Sorry, thou traces. Almost called the trace width gauge. So now we can just sort of position this. We'll move that trace away, such that it's a bit like a power switch. You know, this is only really for testing. I'm not going to put an actual toggle switch in here for something that isn't going to be needed. You know, depending on how this board gets built, you bridge it or you don't. If in, you know, the production boards, I decide that yet they have to be powered sort of separately, then I can just apply some solder paste. So make an opening, an aperture in the stencil, and then that will get automatically shorted by the solder paste in the reflow process. But for now, that's fine. That label, big giant label, is so gross. I don't like that at all. We get to cleaning up the silk screen in a little bit. All right, this is looking pretty good. Our routing's pretty much down. What I done, not down. What I am going to do is we're going to get rid of that trace and instead add a pour there. With an 8 thou width to here. I'm just going to fully enclose that. Lovely. And then just lay down some vias inside of that. Like so. Very cool. Okay. Now switching over to our bottom layer here. Yes, we want to add a via there for the input of that 5 volts. So we don't need to go through that ferrite bead again. We can just put a big chunky 40 thou trace to run all the way over to why is that highlight color so light? Don't like that. Like so. Then we've got a nice, it's not the prettiest solution in the world, but it's going to work just fine to get that 5 volts over here to our the input to that filtering circuit. Okay, and then we can tap our other 5 volt requirements off that line. Oh, we also haven't connected ground to those transistors there. Let's do that. We can just run this directly over there and then chuck some vias in accordingly. And that'll probably do us for today. We didn't quite get to wrapping up the assembly files, but really all we're going to need to do next week is sort of finalize this board. To finalize the board is just run those 5 volt lines, tidy up the silk screen, and then we can send it away for a first prototype, which is going to be really exciting. So that's all for today, guys. Hour and a half. Tune in next week. We're going to be polishing this guy off and getting it into the world. So yeah, it'll be same time, 8:30 a.m. Australian Eastern Standard Time on Tuesday, which will be, what date is that? That'll be the 4th of October for us. So see you there. Bye.